Okay. Now Telos B and XB, these are I have already discussed, and also the sensors. Now these are the different types of sensors that, and what is the dimension and size of those sensors, that also I have discussed. WEC 1/00, Rene 1/00, Mica 1/02, Mica 2. So these are the different types of sensors and their dimensions that I have discussed. And also I have discussed about that what is the configuration, like your CPU, then flash memory, then RAM, RAM, what should be the RAM size, and what is the speed of sending the data. So out of this, you can see that the Mica Z has the highest speed of 250 kbps. So which is to nowadays nothing, because nowadays each of the sensors are capable of sending the data at least with 500 kbps or 700 kbps. Okay, and this is the dimension of each of the sensor nodes. You can see that the mica, the first hand sensors. So it is a coincide sensor, and this time, so this PPT has been prepared in 2010 actually. So this time, so these are actually the modern sensor nodes. So Barclay Smart Dust, COTS Dust, Wings, Rockwell Wings, and these are actually created by different universities only. And already we have shown you what are the components, basic components of a sensor. So what are the basic components of the sensors? Can anybody tell me? Kaushik, can you tell me what are the basic components of a sensor? Yes or no?
Hello, sir.
हाँ बोलो कौशिक. Yes, Kaushik, I can hear you. What are the basic components of a sensor? Yes
Sir,
or
now
no?
hello,
हाँ बोलो.
hello.
बोलो, I can hear you.
हाँ सर, बेसिक कंपोनेंट सर वो प्रोसेसर रहेगा, स्टोरेज, पावर, देन एडीसी, देन सेंसिंग यूनिट, ट्रांसीवर एंड लोकेशन फाइंडिंग यूनिट सर.
पहला तो ये है तुम्हारा कुछ ऑक्सिलरी यूनिट्स रहेगा. ऑक्सिलरी यूनिट्स मींस ऑप्शनल यूनिट्स like GPS or the mobilizing unit. Then what are the things will be there? Power will be there. Then processor power will be there. Then processors will be there. Then what
Storage,
ADC converter? ADC converter will be there, right?
yes, and transceiver.
एक analog to digital converter.
Yes, sir.
Okay. So if you look at this, so this is the power unit and this is the power connector switch, and this is your processor and this is your transceiver. And one transceiver should also be there. Transceiver means what? Transmitter plus receiver. So this antenna will act as the transmitter plus receiver, and this is external radio frequency connector, so which will take the radio frequency. Okay. Apart from this, those who are the optional units are there. Here, the optional units are acceleration, magnetic power options, then light, then temperature, then acoustic, then sounder. So these are the your optional units that are present within your sensors. So this one is actually Mica Z, which follows the ZigBee protocol. So earlier we have told you about the ZigBee protocol. Can you remember? That is SLOPAN protocol that we have discussed earlier, SLOPAN. So which is basically IEEE 802.15.4. Can you remember? भूल गया.
Yes, sir.
एक्सलोपैन के बारे में बताया था ना. So एक्सलोपैन is basically ZigBee standard protocol. So Mica Z also follows this ZigBee standard protocol. Whatever sensor nodes I have told you today and yesterday, out of this, Mica Z is the most robust protocol, robust sensors out of all the protocol, all the sensors. That is why Mica Z size is also a little bit high. If you see the comparison that I have shown to you earlier, you can see the comparison here. Can you see the comparison table? In that you can find out that the Mica Z configuration is the highest configuration. It has the CPU of 4 megahertz, it has the flash memory of 128 KB, RAM size is 4 KB, as well as the speed is 250 kbps. It's the highest speed it consists of. Okay, so the if I consider the modes, different types of modes, we have the Mica 2, Mica 2 dot, Mica Z. These are the different types of modes are there, and these modes are basically having Atmega 128L microcontroller. So 8 mega 128 microcontroller is an 8-bit microcontroller, but actually we use in most of our usage in case of sensors, we use the Arduino microcontroller, right? So in Arduino also basically uses Atmega microcontroller, Atmega, but it is 132. It's a little bit higher version of Atmega 128 microcontroller, that is Atmega 132, that is being used by Arduino. Okay, so it has a 128 KB program flash and 512 KB of measurement flash and 4 KB EEPROM, electrically erasable programmable ROM. Okay, and it can run with two pencil battery, AA size battery, and existing tiny OS code base. So in case of Arduino, we have our own interface, Arduino interface, where we write the program and after that we fire the program. Whenever you fire the program, so within your electrically erasable programmable ROM, the program gets fired and the program remain fixed within your EEPROM, and as per the program instruction, your microcontroller as well as the sensor works basically. So that is the basic principle. So in case of modes also, instead of your Arduino interface, they have the tiny OS interface. Tiny OS is a small lightweight operating system. So TinyOS is an event-based style help for the students understanding. So it's a time constant based. Code structure is open source and very light. And that time, so it can handle more than 200 sensors for the simulation purpose. You have seen the OpNet simulator, right? Where we can work with 10,000, more than thousands of sensors, and we can check that how they are behaving. We can change the protocol stack, everything, right? Kaushik, you have seen in OpNet?
Yes, sir.
Huh? So yeah, OpNet is a much more higher upgraded version, whereas TinyOS can handle only 200 numbers of sensors, and it's a lightweight operating system. So that basically through this, basically it acts as an interface to get the data, fetch the data, and also if I want to write any code onto the sensors. Okay. You can see the TinyOS interface over here. Can you see? Okay, fine. So here you can see that from which interface it is getting the data and at which speed it is getting the data. The data speed is you can see that 38,400 baud baud rate. Baud rate and bit rate is little bit different. 38,400 means actually 38 kbps. So in 38 kbps baud rate speed, it is getting the data. And what is the data format? You can see that the data format is quite like this. This is the data format. So it is written in the hexadecimal manner, and that hexadecimal data will be converted to actual numeric, decimal data to get your data. Is this clear? How you can fetch the data through TinyOS from the Mica modes sensors? This is basically the interface. Is there any question up to this? Student, is there any question? Yes, no, कुछ तो बोलो. देवर्षि, ये टाइनी वेव्स के बारे में तुमको समझ में आया?
सही है सर.
समझ में आया? तो मैं क्वेश्चन पूछूं तुमको?
पूछिए.
अभी क्या बिस्तर पे ही हो या उठ गए?
सर नहीं, तो उठ गए.
उठ गया? ओके फाइन. बोलो, व्हाट इज द डिफरेंस बिटवीन बॉड रेट एंड बीट रेट? यहाँ पे बॉड रेट लिखा हुआ है ना?
हाँ
So
सर.
what is the difference between baud rate and bit rate?
सर बॉट रेट केबीपीएस में है.
हाँ, bit rate क्या MBPS में?
बॉट रेट बॉट.
Who can answer?
सर
नेटवर्किंग में ये तुमको पढ़ाया गया.
सर बीट रेट में तो पर सेकंड में कितना बीट जाता है सर, बट बॉड रेट में तो शायद पर सेकंड में कितना सिग्नल जाता होगा वही था शायद.
Exactly. Very good. Very good. So actually, in case of bit rate, baud rate is basically in parts second. Uh, bit rate is basically in parts second how many bits are going. Okay. And in baud rate in parts second how many signals that are carrying those bits are going. Suppose in bit rate is 4 bits per second, 4 bps. That means 4 bits are going in the 0 1 0 and 1. So these 4 bits are going over there. So that is your bit rate. Now baud rate means how many signals that carrying these 4 bits are going. That is called your baud rate. It is not like that. अगर 4 bits है तो 4 signals will go. इससे ज्यादा भी सिग्नल जा सकता है, इससे कम भी सिग्नल जा सकता है. It depends upon how many bits are being represented by a single signal. Is this clear to you, students? क्लियर नहीं है? नहीं है तो बोलो. सब कोई चुप है, इसका मतलब है इट्स क्लियर. Then I should ask a question to yes or no. Yes or no, tell me. Is it possible every time
Yes,
that
sir.
a
Hello.
single signal will carry a single bit? Can you give an example where one signal is carrying 2 bits?
Sir, I'm not sure.
Then why you remain silent whenever I ask that is it clear to you? So look at these cases. So don't remain keep mum. इससे कोई फायदा नहीं है. Try to understand all, conceptualize all those things. Suppose I have this signal. Digital signal. This one consists of 0, this one consists of 1, this one consists of 0, this one consists of 1. So how many signals are there? 1, 2, 3, 4. So 4 signals and 4 bits. Now tell me what is my baud rate over here? Yes or no, tell me what is the baud rate? And what is the bit rate? Girija, tell me what is the baud rate? 4 signals, the number of, what is baud rate? Baud rate is number of signals that is carrying the bits per second is called baud rate. So how many signals are carrying these 4 bits?
सर 1 बॉड रेट होगा ना, 4 सिग्नल बाय 4 बीट.
हाँ तो 1 baud rate क्यों होगा? 4 baud rate होगा ना?
हाँ सर
4
4 बॉड
signals
रेट.
are carrying
4.
those 4 bits.
यस सर 4 बॉड रेट.
So it should be 4 baud per second. And what is the bit rate? 4 bits per second, BPS. So here baud rate and bit rate are same. Yes or no?
Yes, sir.
Now, what I have done that here minus 5 volt I have considered as minus 1 or 0, and plus 5 volt I have considered as 1. Now I am changing the representation policy. What I am doing that I will consider in between minus 5 volt and plus 5 volt there are 4 voltage level. One voltage level will be plus 2.5 volt, another voltage level will be minus 2.5 volt, and plus 5 volt and 0 volt. Okay, so what I will do that I will represent plus 5 volt as 1 1, plus 2.5 volt as 1 0, minus 2.5 volt as 0 1, and minus 5 volt as 0 0. If I represent like this, then what is my first two bits is 0 1, right? Now to 0 1, to represent 0 1, which voltage level I require? Minus 2.5 volt. So that case, I should start from here, minus 2.5 volt. And what is my next bit? Next bit is again 0 1. So again it will be minus 2.5 volt. Now with two signals, I am representing these two signals means the first signal is minus 2.5 volt, that is representing my 0 1, and then next 2.5 volt which is also representing my 0 1. Ultimately, I can represent this 0 1 0 1 4 bits with two signals only. Two signals means two baud rate, right? Here it is 2 baud per second. And what is the bit rate? Bit rate is 4 bits per second. Now tell me, here is the baud rate and bit rate is same?
No, sir.
Now is this clear to you?
Yes, sir.
Now is this clear to you?
Yes.
Now, which one is better? For baud rate and bit rate same is better, or baud rate lower than bit rate is better?
So baud rate lower than bit rate.
Baud rate lower than bit rate, because with the low number of signals, I can send very high number of bits. Yes or no?
Yes, sir.
Okay. Now, do you know in your current situation you are using modem? That modem speed is 2 Mbps. Modem speed is 2 Mbps. Now, in that 2 Mbps speed modem, do you know how many bits are being represented in by one signal? 128 bits are being represented by one signal. Now, if I make more number of bits to represent with one signal, that case my signal level will be also higher. Here you can see that to represent 2 bits in one signal, how many voltage level I have to consider? 4 voltage level, yes or no? To represent, you can see over here, to represent 2 bits with 1 voltage level, I require 4 voltage level. One is 1 1, one is 1 0, one is 0 1, and that is 0 0 0. 4 voltage levels are being used. Please go outside, I'm taking class. So 4 voltage levels are being used, right? Now, to represent 3 bits with 1 voltage level, then how many, with one signal, that case, how many voltage level will be required?
Sir, 8.
8. Very good. That means I have to divide this from plus 5 to minus 5. I have to take 8 different voltage level, right? देखो 3 बिट को रिप्रेजेंट कर रहे हैं एक सिग्नल से, आई रिक्वायर 8 डिफरेंट वोल्टेज लेवल. 4 बिट को अगर रिप्रेजेंट करना है तो कितना वोल्टेज लेवल चाहिए?
16.
16. 5 बिट को रिप्रेजेंट करना है तो कितना वोल्टेज लेवल चाहिए?
32.
6 बिट को अगर रिप्रेजेंट करना है तो कितना वोल्टेज लेवल चाहिए?
64.
हाँ
64.
64. 7 बिट्स को अगर रिप्रेजेंट करना है तो कितना वोल्टेज लेवल चाहिए?
128.
128। आप सोचो 128 बिट को अगर रिप्रेजेंट करना है तो कितना वोल्टेज लेवल चाहिए?
2 to the power 128.
2 to the power 128।
सर ये
Now,
तो बहुत
now
चल
can you
रहा है।
imagine तुम्हारा ये 10 वोल्ट को कितना छोटा छोटा वोल्टेज लेवल में ये वो रिप्रेजेंट कर रहा है?
यस सर।
वोल्टेज लेवल का डिफरेंस कितना कम होगा? And everything is being done by only one device, that is called modem, which is inbuilt in your mobile. He is doing all those subtle things. That is why it cannot suffer a slight voltage fluctuation. जो एक्सटर्नल मॉडेम होता है ना, वो थोड़ा भी अगर वोल्टेज फ्लक्चुएशन होता है तो वो एक्सटर्नल मॉडेम सबसे पहले खराब हो जाता है। और जितना ज्यादा बिट्स एक सिग्नल से तुम पास करा पाओगे उतना ही तुम्हारा मोबाइल का नेटवर्क स्पीड ज्यादा होगा, because your signal passing is limited, right? You cannot pass more than more signals after a certain limit. But if I can pass more bits within the same signal, that case my speed will increase. Now, is this clear? Now, why there are several types of modems were being earlier discussed, that 56 kbps modem, आप लोगों ने नाम सुना होगा 56 kbps modem या 16 kbps modem. Right now, we have 2 mbps modem. We have 2 mbps modem. So they have this much of capability. ये क्लियर है आप लोगों को या shall I explain it again? See, I am going to ask the same question again and again in the next class. Is it clear to you, students? Yes or no? Now, is this clear?
Yes, sir.
Is this clear, na? Bit rate, baud rate, modem. Okay, fine. Okay, so there are several types of coordinators that there earlier we have seen. These are the whatever mica, mica Z, mica mode. So these are the basically the microcontroller integrated with the sensors. So if we consider about the independent microcontroller, we can have Raspberry Pi, we can have Arduino, we can have Intel Galileo. Intel Galileo is also a very strong microcontroller, but its cost is little bit higher, more than 5,000. So if you can afford this one, so you can also take this one. But each of the microcontroller does not have any transceiver. You have to connect the transceiver separately. Transceiver means transmitter plus receiver. In one word, or in simple word, I should say that each of the microcontrollers are not connected with your antenna. Antenna is not there. You have to connect the antenna separately. इसलिए हम लोग कभी कभी क्या करते हैं, नोड एमसीयू माइक्रोकंट्रोलर यूज करते हैं. तो नोड एमसीयू इज द काइंड ऑफ माइक्रोकंट्रोलर व्हिच इज connected with the, which is inbuilt, which has the inbuilt Wi-Fi module, which has the inbuilt your radio frequency devices are connected with it. Okay. Now the sensor node communication. In the sensor node communication, already I told you there are two types of communications are there. One is called single hop communication. Another is called multi-hop communication. So in case of single hop communication, these are the different sensor node and they are sending the data directly to the sink. Sink means your sink may be your mobile tower or your wireless sensor network node head, which is getting all the details, WSN tower. So this tower may be a distinct tower, or this tower may be your mobile tower where it is getting the data, and from that it is sending the data directly to the cloud. And this sync will always be connected with your backbone network. So it will always be connected with your backbone network. Now, and in case of the multi-hop communication, what happens that this sensor will send the data to this sensor will send the data to this sensor, and after that, the sensors which is geographically nearer to sync, he will collect all the information on behalf of their neighboring sensors, neighbor to neighbor sensors, and then it will sync to this, it will send the data to the sync. So it is not like that the neighboring sensors are only one. Here you can see the three neighboring sensors are there. They are collecting the data from the different locations and sending the data to the sync. Now tell me which one is better? Single hop communication is better or multi-hop communication is better?
So multi-hop.
Multi-hop. Why?
सर डिफरेंट नोड से हम लोग जाएंगे ना सर, हॉपिंग काउंट सर, उससे मतलब कोई भी अगर बीच से कोई भी नोड अगर टूट जाता है तो फिर सर दूसरा हम लोग नोड सिलेक्ट कर पाएंगे तब हॉप काउंट के लिए सर।
नहीं, why I need those things? ये अगर हॉप काउंट ये सब छोड़ो, सब कोई अगर ऐसे डायरेक्टली सेंड करता तो क्या प्रॉब्लम होता है? लास्ट डे आई टोल्ड अबाउट दिस वन. अगर सब कोई अगर डायरेक्टली सेंड करता तो
सर पावर डिसिपेशन ज्यादा होता।
Exactly, power dissipation बहुत ज्यादा होगा. The nodes which are geographically located in a far distant, that case that node has to fetch up more power to send the data in a distant node.
यस सर।
आप लोग जानते हो अगर तुम सैटेलाइट कम्युनिकेशन मतलब जीपीएस अगर ऑन करके रखोगे, अब जो जीपीएस तुम लोग ऑन करते हो वो है असिस्टेड जीपीएस, वो एक्चुअली गूगल से लिया हुआ जीपीएस डेटा. अगर तुम एक्चुअल जीपीएस डिवाइस को ऑन करोगे ना, व्हिच इज गोइंग टू कनेक्ट विद योर सैटेलाइट डायरेक्टली, उसका पावर डिसिपेशन बहुत हाई रहता है. मैंने देखा विद इन 10 मिनट्स मेरा पूरा बैटरी ड्रेन होके पूरा पावर चला गया. Why? Because they need to connect to the transponder of the GPS satellite. So it requires huge amount of power. Why? Because it is in a distant place. Even सबसे इससे भी और भी आसान एग्जांपल दे रहा हूँ. जब तुम लोग ट्रेन से मूव करते हो, तुम्हारा मोबाइल बैटरी कितना ज्यादा जल्दी ड्रॉप होता है कि नहीं? मोबाइल जल्दी गर्म होके जल्दी तुम्हारा बैटरी ड्रेन आउट होता है कि नहीं? यस और नो?
यस सर।
यस सर।
या बस में जब चलते हो, बस में फिर भी कम होता है, ट्रेन में बहुत ज्यादा होता है. व्हाई? बिकॉज व्हेन यू आर मूविंग थ्रू ट्रेन, योर नेटवर्क इज चेंजिंग बिकॉज यू आर गोइंग थ्रू सेवरल टावर्स. एक टावर से तुम डिटैच होकर दूसरा टावर पे आ रहे हो, एंड ऑल आर इन ए डिस्टेंट प्लेस. मोस्ट ऑफ देम आर एटलीस्ट 5 kilometers away from the railway track. Now to find out the new tower and connect with the tower and then detach with the tower within 5 minutes and connect with the new tower, every time ये होता रहता है. And whenever you are going to send a signal to a distant tower, you require more power. And if you require more power, your battery will get drained down fast. So if you have to send a data or send a signal from your device, whether it is a mobile device or sensor device, whatever it may be, you have to dissipate more power, more energy. So to save your power, what do we do that? We send the data through multi-hop communication. We try to send the data through multi-hop communication system. Now is this clear?
यस सर।
Okay. So look at this, how it is being connected with the gateway, though all those things are being described. So this is basically one animation through which it may be clearer to you. So they are creating multi-hop communication path. Even there is a one big question is that at the time of sending multi-hop communication, I may have multiple numbers of neighbors. So which neighbor I should send the data so that it should send to the sink. Here the sink is your gateway. So this gateway is your sink. So this gateway is your sink. So how which path or which neighbor I should choose so that my data will go directly through to my thing. So how can I judge them? So it depends upon whether I am getting any signal, proper signal from my mobile nodes or not. Here you can see that there is a communication barrier is coming. So I am not getting proper signal from this node. So immediately what it is doing that instead of making it as a neighboring node, it is making this one as a neighboring node. Though it is taking longer path, still it is taking this path only so that it is being sure that my data will go properly. Okay, so it is not like that if it is nearer to me, if I don't get any signal from that the nearer nodes, so that case I am not going to send my data though it is nearer to me, because that node may be a dormant node, that node may be a sleeping node. So neighboring node selection is also a big task for the wireless sensor network. So you have to be cautious, because if I don't get any signal from my neighboring node, what will happen that I have to wait for sometimes, and whatever data I am sending, that data may not be reached to the neighboring node in a time. तुम जो जो डेटा यहाँ पे भेज रहे हो, most of the data will get lost. Is this clear, students?
Yes, sir.
Okay. Any question regarding this? Any question? Okay, so if there is no question, then I am going to end up the session over here.
सर
हाँ, बोलो।
हेलो सर सर वो सर पार्थ का जीडी चल रहा है सर, इसीलिए वो आज नहीं आ पाया था सर।
क्या जीडी चल रहा है?
सर वो जारो एजुकेशन का जीडी है सर उन लोगों का।